In this problem, we are asked to go from bromocyclohexane to this decently complex molecule here, and we're asked to propose a synthesis for this transformation, an efficient synthesis, that is. So when I first approached this problem, I said to myself, okay, well, I don't really in my head have a plan for how I'm going to get to there. So how about I just work a little backwards to make this more simple? From chemistry, I already know. Okay, so this is an ester, right? And so I'll say for the retro synthesis, I'll just write retro. So this is our product, right? So we're going to work backwards till we get something that we can make from bromocyclohexane quite easy. Okay, so let's work in going that way. Well, I know that I could make this from an anhydride. Right? I could use it, I could make this from an acyl chloride. I could make it from, yeah, that's about it, right? Maybe an amine if I really push the conditions. But we're gonna make this from, and we're gonna use an acyl chloride. Okay? So we know that if I were to use an alcohol here, so HO, and in this case, if we want 2 carbons, we're going to want to use ethanol, right? And we're going to use an acid to really accelerate that process to go and drive towards our product, okay? Now, let's come this way. How can we make this acyl chloride? That's a good question. Well, I know that if I use a carboxylic acid, using SOCl2, I can go from a carboxylic acid to an acyl chloride. I could also use PBr3 if I wanted to say make that chlorine a bromine. It would be an even better leaving group. Maybe make this reaction occur even better. But let's just keep it at SOCl2. Doesn't really matter which way you go in this case. Okay, so we have a carboxylic acid. Now I ask myself, can I easily go from bromocyclohexane to that carboxylic acid? Can I really? It looks a lot better than going from the ester, I'll tell you that, right? That ester was very intimidating. The answer is yes, you can actually, in fact, go from the bromocyclohexane to the carboxylic acid here. All right? I know that if I have a Grignard of my cyclohexane, and if I were to react this with, say, CO2 and some sort of acid, right, as a workup step, well, then you're going to get this, right? And even working backwards even more, we can just go right from our starting material. If we use bromocyclohexane, we throw magnesium. We throw magnesium in diethyl ether, so Et2O, right? We know we're going to get our Grignard, right? So we use then CO2HCl, we get our carboxylic acid, SOCl2 to get our acid halide, and then we use our ethanol with acid catalyst, and we're going to get our product. That is actually the synthesis for this reaction here. If you guys did enjoy, please like, subscribe, and comment. If you have any alternatives that you were able to deduce and want to check, go on ahead and drop it in the comments. I'd love to review it and maybe give you some feedback on that. Have a wonderful day.